Let's solve wiggle sort, which we want to try and solve with minimum complexities of O n log n time and O n space. So the problem statement gives us an array of integers, and we need to reorder it in such a way that satisfies the wiggle condition as shown. We can assume that the input array always has a valid answer. So we have four possible methods to achieve this wiggle sort. A. Sorting and swap operations. B. Insertion sort. C. Bubble sort. Or D. Selection sort. I'm going to give you a couple of seconds while you think about this. So, for those of you who are able to get it, congratulations. And for those of you who just want to see the code, the answer here is A. Sort and swap operations. There is a naive approach to solving this, and I'm not going to go into the details, but we can generate all permutations of our input array, and then check each to see if it satisfies the wiggle condition. Obviously, I don't recommend even attempting to code that in a real interview situation. However, in our optimized solution, we can achieve the wiggle sort by performing a careful sort followed by some swap operations. And as you can see, it's quite a short code. In this, we sort the array in ascending order. Then we iterate over the array starting from the second element at I equals 1, or index equals 1, and we swap adjacent elements so that we're satisfying the wiggle condition. Note that we're taking a step of 2 each time. And that really is it. I hope that it's relatively intuitive for you. Let's take a look at the line by line just to make sure here. So we get the size of the nums vector and we assign it to n here. After that, we sort the elements in the vector in ascending order, and this ensures we have the smallest elements towards the beginning of the array, and of course all of them in order. We then start our for loop, which begins from index 1, the second element, iterating over the array with a step of 2. This means we only consider elements at odd indices each time. And inside the loop, we swap the current element, nums I, with the next element, nums I plus 1. This operation helps satisfy our wiggle condition, ensuring nums I is greater than or equal to nums I plus 1. After the swap, of course. Finally, the function ends, and in this case the modified nums vector contains the elements reordered to satisfy the wiggle condition. Note that we don't need a return value here. So that's it, and that's another problem solving session completed with Coding Card Sharp, where we've used one of these four methods to solve the wiggle sort. Hopefully you'll remember that we can do this with careful sort and swap operations. Our application does give some reasoning as to why this works. And if you still need help, we have code in C++, Python, and Java as well. It would also be remiss of me to forget where this solution actually came from. I learned how to do these kind of coding interview challenges from this course. I'd strongly recommend checking out the link which is in the description to this YouTube video. Finally, thanks very much for watching. The next problem that will be covered in the playlist is a slightly more challenging problem, but one that I enjoy doing. Eliminate maximum number of monsters.